In this lecture, we discussed about the logical instruction of 8085 microprocessor. These instructions perform logical operation on the data stored in register, memory, and status flag. The logical operations are AND, OR, and XOR operation, also rotate, compare, and complement operation. Now, AND or XOR operation. Any 8-bit data or the content of register or memory location can logically have AND operation, OR operation, XOR operation with the content of accumulator, and the result is stored in accumulator. Now, logically AND register or memory with accumulator. After execution of this instruction, the content of accumulator are logically ANDed with the content of register or memory, and the result is placed in the accumulator. If the operand is a memory location, then the address is specified by the content of HL pair. After execution of this instruction, the flag register, sign flag, zero flag, parity are modified to reflect the result of operation. The carry flag is reset and auxiliary flag is set. For example, logically AND with register B. After execution of this instruction, the content of accumulator is changed according to content of register B, and the flag is set according to the status of the accumulator. Here auxiliary carry flag become set. Now logically AND with memory. Here the location of memory is specified by the content of HL pair register. After execution of this instruction, the content of accumulator become changed according to the content of accumulator and the content of memory, and the flag is modified according to the status of the result of accumulator. Now logically AND immediate with the accumulator. Here the content of accumulator are logically ANDed with the 8-bit data given by the instruction, and the result is placed in accumulator. Also, the sign flag, zero flag, and parity are modified to reflect the result. Carry flag is reset and auxiliary carry become set. For example, logically AND with data 3F. Here, the content of accumulator is ANDed with the data 3F, and the result is set in accumulator, and flag is also set according to the content of accumulator. Now, logically OR with register with the content of accumulator. Here, the content of accumulator are logically OR with the content of register or memory. Also, the result is stored in accumulator, and for any memory location, the address is specified by the content of HL pair. Flag register also modified to reflect the result, and carry flag and auxiliary flag both are reset. For example, logically OR with register B. After execution of this instruction, the result is stored in accumulator, and the content of register B are same as the before. The execution of this instruction. Now, logically are with memory. Here, execution of this instruction, the content of accumulator is modified according to the result of this instruction, and the carry flag and auxiliary carry are reset. Now, logical are immediate with the accumulator. Here, the content of accumulator are logically are with the 8-bit data given by the instruction, and the result is placed in the accumulator. Also, the flag are modified to reflect the result, and the carry flag and auxiliary carry are reset. For example, logically are with 08 data. Here, the content of accumulator and the data are odd, and the result is stored in the accumulator, and both the carry flag and auxiliary flag are reset. Now, XOR operation. This instruction is used for logical OR with register or memory with the content of accumulator. In this instruction, the content of accumulator are XORed with the content of register or memory. The result is stored in the accumulator. If the operand is memory location, then again the address is specified by the content of HL pair. Again the flag are set according to the operation of the result, and the carry flag and auxiliary carry are reset. For example, XOR with register C. Here the register C has a data and it is XORed with the content of accumulator. After execution of this instruction, the result is stored in the accumulator, and the auxiliary carry and carry flag are reset. Again, the XOR with memory. Then, after execution of this instruction, the result is stored in accumulator, and carry flag and auxiliary carry flag are reset. XOR immediate with accumulator. After execution of this instruction, the content of accumulator are XORed with the 8-bit data, and the result is stored in the accumulator. For example, XOR with 39 data. After execution of this instruction, the result is stored in accumulator, and both the carry flag and auxiliary carry are reset. Now, for compare operation, any 8-bit data or the content of register or memory location can be compared for equality, greater than or less than with the content of accumulator. In this operation, the result is reflected in status flag. Here, this instruction is used to compare register or memory with accumulator. The content of operand are compared with the content of accumulator. After execution of this instruction, the content are not changed, but after this instruction, only flags reflect the result of operation. Take example. Compare register D, which means the content of register D is compared with the content of accumulator. Now, as shown in this example, the content of register D is greater than the content of accumulator, then the carry flag becomes set, which shows the register is greater than the content of accumulator. And both the data are not changed. Now compare with memory. Here again, the memory location is specified by the HL pair. After execution of this instruction, only flag register are set. In this example, the content of memory location and the content of accumulator are same. So, the 0 flag becomes set, which shows that both the data are same, and this flag become set. Now compare immediate with accumulator. In this instruction, the 8-bit data is compared with the content of accumulator. The values being compared remain unchanged. That is, the data of accumulator is not changed, only the flag status reflect the result of operation. For example, compare with 30H data. Here, the data is compared with the content of accumulator, and after execution of this instruction, only carry flag and auxiliary carry become changed according to the execution of this instruction. Now, for rotate operation. In this instruction, each bit in the accumulator can be shifted either left or right to the next position. Now, this instruction is used to rotate accumulator left. In this instruction, each binary bit of accumulator is rotated left by 1 position. The bit 7 is placed in the position of D0 as well as the carry flag. The carry flag is modified according to the bit D7, and the flag are not unchanged. As shown in this diagram, every bit is moved to left, and the B7 data is stored in carry flag. After execution of this instruction, the carry flag shows the bit of D7, and the D7 bit is also placed at the D0 bit position. This instruction is used to rotate accumulator right. Means each binary bit of accumulator is rotated right by 1 position. Bit D0 is placed at D7 as well as the carry flag. That is, the carry flag is modified according to the bit D0. As shown in diagram, the carry flag is set according to the bit position of D0, and D0 bit is similar to the bit of carry flag. Now, rotate accumulator left through carry. That is, each binary bit of accumulator is rotated left by 1 position through the carry, and D7 bit is placed in the carry flag, and the carry flag is in the least significant position D0. The carry flag is modified according to the bit D7, and the flag are not affected by this instruction. As shown in diagram, the D0 bit is moved to the carry, and the carry bit is shifted to the D7 bit. And after execution of this instruction, the bit value of D0 is in the carry flag, and the carry flag bit is moved to the D7 bit position. Now, complement accumulator. In this instruction, the content of accumulator are complemented. No flag are affected. Means whatever the value of accumulator is complement, means here as shown in example, the accumulator have 0 values. Then after this instruction, the accumulator becomes FF. This instruction is used to set carry. The carry flag is set to 1. After execution of this instruction, the carry flag are become set. Now, these all are the instruction used for the logical operation, and in next lecture we discussed about the control instruction used for 8085 microprocessor operation. Thank you.